result of those derivatives. If y equals to sine x, what will be dy dx? Dy dx, dy dx equals to cos x. So if y equals to sine 2x, then dy dx equals to cos 2x. Now differentiate 2x, you have 2. So that is what you are going to have. So if y equals to sine 3x plus 2, dy dx, then dy dx equals to cos 3x plus 2. Now differentiate 3x plus 2, you have 3. That is what you are going to have there. That is what you are going to have. So if dy dx equals to will be equals to what? Cos cube x. Now differentiate this, you have 3x. But that is what you are going to have there. So if y equals to sine 3x plus 8 all raised to the power of 5, then dy dx equals to cos 3x plus 8 all raised to the power of 5. Now differentiate 3x plus 8 all raised to the power of 5. You have 5 into bracket 3x plus 8 all raised to the power of 4. Now differentiate into bracket 3x plus 8 all raised to the power of 4 cos 3x plus 8 all raised to the power of 5. So this is derivative of sine. So we are going to talk about derivative of cos. Dy dx equals to minus sine x. That is, now if you differentiate cos, you are going to get minus sine. So if y equals to cos 2x, then dy dx equals to minus sine 2x. Now differentiate 2x, you have 2. So that is what you do when solving objective questions. If y equals to what should we call it again? If y equals to cos 8x plus 5 all raised to the power of 10 equals to 8 cos 8 minus 8 sine 8x plus 5. That is, if you differentiate the power of 8, then dy dx equals to minus sine 6x plus 2 all raised to the power of 8. Now differentiate this. You know, if you differentiate this, you have what? 8. You have 8 into bracket 6x plus 2 all raised to the power of 7. Now differentiate the bracket, you have 6. So finally you have 8 times 6, that will give us 48. 48 into bracket 6x plus 2 all raised to sine 6x plus 2 all raised to the power of 8. Don't forget the minus sign. We will have minus sign there. So this is what you do when solving objective questions. Y equals to tan x. If y equals to tan x, what will be our dy dx? Dy dx will be what? Sec. Then 2 equals to sec square x. You may interest to know why we differentiate tan and giving us sec square x. So now you know that in mathematics y equals to tan x, abi? Tan x could be written as sine x all over cos x. So using quotient rule, we have v. So that's it. We have v du dx minus u dv dx all over v squared. If you substitute this, what's our v? Our v is cos x. What's our du dx? Differentiate this. When you differentiate sine, you get cos. You have cos x. Now we have u. What's our u? Sine x. You have sine x. If you differentiate the v dx, differentiate this, you have minus sine x. Don't forget, all over everything over v square over cos s all square. So finally, what are we going to have? Because cos s times cos s will give us cos square x. Minus sine x times minus sine s will give us plus, because minus times minus will give us sine square x all over cos square x. There is a trigonometric identity that says that sine square x plus cos square x equals to 1. or cos square x plus sin square x equals to 1 over cos square x. So another way to write this is 1 over cos x dot 1 over cos x. That will give us sec x, because 1 over cos x will give us sec x. Another 1 over cos x will give us sec x. So that will give us sec square x. That is when you differentiate equals to, if y equals to sec x, then dy dx equals to, dy dx will be equals to what? Sec x tan x. That is, if you differentiate sec, you are going to get sec tan. So if y equals to sec 2x, then dy dx equals to sec 2x tan 2x. Now differentiate 2x, you have 2. That is what I'm going to have. If y equals to what should I call it? Sec 3x plus 2, then dy dx will be equals to what? Dy dx will be equals to sec 3x plus 2 tan 3x plus 2. Now differentiate this, you have 3. So that y equals to cosec x. What will be our dy dx? Let's just play with it. Y equals to cosec x. So that means y equals to 1 over sine x. So using quotient rule, we have y equals to cos sec sine inverse of this. So using that, we have dy dx direct. Dy dx equals to what? So when we first divide, minus 1 sine x raised to the power of what? Minus 2. Now differentiate the bracket, you have cos x. So finally, what are you going to have from there? We are going to have, if this one comes down, we have minus cos x all over sine square x. That is what we are going to have there. So for example, if you have dot 1 over sine s. So you know that 1 over cos s will give us cot x. It will give us cot x. That will give us cot x. That will actually give us cot x. So 1 over this will give us what? Will give us 1 over this. Will give us what? Will give us cosec. So if you differentiate, if y equals to cosec x, dy dx will be equals to minus cot s cosec x. That is what we are going to have from there. So if I differentiate that, that will give us minus cot s to cosec x. Then dy dx equals to minus cot s cosec x. So if y equals to cot cosec 8x, then dy dx will be equals to what? Will be equals to minus cot 8x cosec 8x. Now differentiate 8x, you have 8. That is what you are going to have. 8x plus 5, then dy dx equals what? Dy dx will be equals to what? Dy dx will be minus cot 8x plus 5 cosec 8x plus 5. Now differentiate 8x plus 5, you have 8. That's what you are going to have. Y equals to cot x. What will be our dy dx? We can quickly play with it. So that means we have y equals to 1 over tan s. Because 1 over tan x will give us cot x. So that means what we are now saying is that y equals to tan inverse. So if I differentiate this, I have dy dx equals to minus 1. So minus 1 tan s raised to the power of minus 2. Now differentiate this, you have sec square x. So finally you have minus sec square x all over what? All over square x. That is what you are going to have. So if you now have this, let's break it down. We can write this to be what? We can write this to be sec is what? Sec is cos x all over tan square x. What are we going to have? 1 over tan square x. Abi, if I change it to multiplication, I will have 1 over cos square x times 1 over tan square x. That is what you are going to have. So 1 over cos square x will now give us what you now. So finally, cos we cancel cos will come up. We have 1 over cos square x dot cos square x all over what? All over sin square x. So cos square x cancel cos square x. We now have 1 over sin square x. That is what we are going to have there. X, we said our dy dx, what we are deriving, we said 1 over sin square x. So that gives us what? That gives us 1 over sin x dot 1 over sin x. That will give us cosec x dot cosec x. That will give us cosec square x. So that means if you differentiate cot, you get dy dx will be equals to cosec square x. That is what you are going to have. So 3x, then dy dx equals to cosec square 3x. Now differentiate this, you have 3. So if y equals to cot 8x plus 2, then dy dx equals to cosec square 8x plus 2. Now that's what I going to have. Don't worry, we have cosec square 8x plus 2. So this is what you do when solving objective. If y equals to 8x